Okay, this video is going to cover naming covalent compounds and acids. So first you want to know how to recognize that you have a covalent compound, and covalent compounds are made of two nonmetals. So you're looking for two things on the upper right hand side of the periodic table. When you are naming binary covalent compounds, so these are covalent compounds that just contain two nonmetal elements, for example carbon and oxygen, or sulfur and oxygen, or nitrogen and hydrogen, you are going to be dealing with prefixes. So you need to know what the various prefixes stand for. A lot of them are ones you're probably familiar with already. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta. So you need to know what those prefixes are. And when you are naming a binary covalent compound, the first word takes the name of the element with the suitable prefix. The only exception being, if there's only one atom in the first element, you do not use the word mono. So for example, if you had one carbon and one oxygen, you would name it carbon monoxide rather than monocarbon monoxide. So you never use mono on the first word. The second word takes the name of the element with the "ide" suffix and the suitable prefix. So some examples, you can pause for a minute and try these on your own on a piece of paper. This first one is silicon dioxide. So notice how the first element, we didn't do anything to the name, it's just silicon. The second element is oxygen. We change the ending to "ide, so it becomes oxide. And since there are two of them, it's dioxide. The second one is carbon monoxide. In this example, you see we don't use the mono on the first element, only on the second element. Carbon tetrafluoride. So I have one carbon, so I'm just going to write down carbon, and then I have 4 fluorines. So I change the fluorine to fluoride, and I put a tetra in front of it to show that there are 4 of them. We've got tetranitrogen tetraoxide, xenon hexafluoride. Notice I'm only changing the name of the second element to "ide." You do not change the ending of the first element. So dinitrogen trioxide, tetraphosphorus heptaoxide. So you can hit pause and try these problems on your own. And I'll put the answers up. So again, here it's knowing what the prefixes mean. So knowing that di means 2, tetra means 4. Okay, let's talk about acids. So first you want to recognize when you have an acid, formulas for acids usually start with a hydrogen. Hydrogen is the cation, and you will have an anion as well. And there are two types of acids that you can think about. There's acids that contain oxygen and acids that do not contain oxygen. When you're naming oxygen-containing acids, these are the acids that involve a polyatomic ion, such as nitrate or phosphate. So when you're naming acids, you want to look at what the anion is. Oxygen-containing acids have polyatomic anions. And so what you do is you consider what the name of the polyatomic anion is, write that down, but change if there is an "ate" ending to your polyatomic anion, change the ending to "ic. If it's "ite," you change it to "us," and then you add the word acid. So let's look at some examples. HClO4 involves ClO4, which is the perchlorate ion. So I take the name perchlorate, change the "ate" to "ic, and it becomes perchloric acid. H2SO4 involves the sulfate ion. So I take the "ate, change it to "ic, that becomes sulfuric acid. The next one involves the acetate ion. I changed acetate to acetic and add the acid to it. Now we've got some "ite" examples. H2SO3 is sulfite, so that the "ite" ending becomes "us, so sulfite becomes sulfurous acid. HNO2 is nitrite, which becomes nitrous acid. So "ites" become "us, "ates" become "ic." Naming non-oxygen containing acids. These could be monatomic or polyatomic. You will notice that these ones will have the anion naming an "ide." So basically this goes for any anions with an "-ide" ending. So we change the "-ide" ending to "-ic" and add the prefix hydro and the word acid. So example, HCN is cyanide, so that becomes hydrocyanic acid. HCl is chloride, that becomes hydrochloric acid. HBr is bromide, becomes hydrobromic acid. So you've got three possibilities. You've got an anion that names an ide, an anion that ends in ide becomes hydroic. If it ends in ate, it just becomes ic acid. And if it ends in ite, it becomes us acid. So again, you can pause it to try these practice problems. So nitric acid is based on the nitrate ion. So it looks like this. Phosphoric acid is based on the phosphate ion. Phosphate ion has a -3 charge, so notice we'll need 3 hydrogens to neutralize the charge of 1 phosphate. Hydrofluoric, since there's a hydro there, I know it comes from my monoatomic fluoride ion, so that's just HF. Hydrophosphoric acid would be H3P, so if you, again, my monoatomic phosphide ion. This is kind of an unusual one you wouldn't see often. Carbonic acid, since there's ic acid and there's no prefix there, that means it's based on the carbonate ion, which is CO3, so this is H2CO3. Hypochlorous acid, the us ending means it comes from the ite ion, so hypochlorite is the ion you want to look for on your polyatomic ion list. That's ClO, so hypochlorous acid is HClO.